Hello, going to talk some more about constant rate infusions. There are two kinds that I usually think about when I'm going to work with my animals, and one is for the single pet. So I'm just drawing it up for one animal that I'm working with for the day. It will not be transferable to anybody else. And the other kind is for multi-pet, one where I could change out the line and then start that same CRI on a different pet, and it would be run at 1 mil per kg per hour, and that would work for anyone in the hospital. So first you want to figure out what is your drug amount. I'm going to change my pen color so it looks more obvious when I'm highlighting things for you. So you want your weight in kgs. And we almost always start with pounds, right? But we know this. The conversion is 2.2. So if you take your pounds divided by 2.2, you will get kgs. So let's say this is a 14.9 kg animal. The next thing we want to do is choose what is the mg per kg per hour of my CRI. So if you go into your formulary, and Plum showed me that morphine is going to be 0.1 to 1 mg per kg per hour. So I have a huge dose range I could choose from. So I'm going to go right in the middle. 0.5 mg per kg per hour is what I'm going to pick. Then I'm going to go to my next equation. I'm going to take my kgs times the mg per kg per hour that I chose, and that will get me mg per hour. So if I take this 14.9 kgs times 0.5 mg per kg per hour, and let's go ahead and do that, 14.9 times 0.5, and that equals 7.45 excuse me, mgs per hour. So now this is mg per hour. Oh, I'm running out of space. That's all right. Mg per hour. So now once you've got that, you go to your next equation, mg per hour divided by the concentration. And the concentration is what lives on the bottle. So if the bottle of morphine tells me that it is 10 mg per mil, that's its concentration. Morphine comes in lots and lots of different concentrations, so I encourage you to always read your bottle before you start drawing things up. I've seen it written as 1 mg per mil and 15 mg per mil and 20 mg per mil, as well as 10 mg per mil. So make sure you're always looking at what concentration do I have before I start doing the math. And then you've got the last one here again, mg per hour divided by concentration. So you've got that 7.45 mg per hour divided by the concentration, which is 10. And that's going to give you 0.745 mils for each hour. Mils for each hour. Okay. Now, let's say we're setting this up in a bag that's going to be long term. We're going to be running this on this animal for many hours. So next part of the equation, you got to choose size of bag. So we're going to choose something that I think might be a little large, but we'll go with it. 1,000 mils. Maybe this dog was hit by a car, and we know he's going to have pain for days and days and days. And therefore, we want to treat that pain as best we can with a large volume. So 1,000 mils would not be wrong. That would certainly be easy enough to pull up. And then the next part of the equation is figure out what is your rate of that bag. So are we going to run it at a maintenance rate? Are we going to run it at twice maintenance? Are we going to run it something really low? Well, when I did his maintenance rate, I got roughly 50 mils an hour. And so we'll do that. Now we go to the next part, the bag in mils. So 1,000. And that's going to then be divided by the mil per hour we just picked. What rate do we want to run this whole concoction at? Not only to fluid resuscitate the animal and to keep them hydrated, but to trickle in that morphine. So we chose 50, so divided by 50, that gives us 20 hours. So we're going to have 20 hours worth of medicine and fluids running into this animal. So if we put both sides together now, you've got the bag hours that you just figured out, 20, times the mil per hour of the drug we figured out, which is way back here, 0.754 mil per hour. And when you do that math, let's go ahead and do that math. 20 times 0.754, and you get 15.08. Rounding is absolutely allowed because our lives would be silly without it. Ugh, I don't like how I wrote that. So 15.1, because I can draw up 15.1 mils. What if you say, well, I'm crunched for time, I don't want to drop that silly 0.1. You don't have to. That's okay. I would say that a CRI is not necessary to be 100% as accurate as possible, and that's okay. Not to say we shouldn't be doing our due diligence, but the difference between 15 and 15.1 is fairly negligible. That's what I'm thinking about. The difference between 15 and 10 is very negligible. So you see what I said? If I only put 10 mils in this bag, I have a completely different concentration. But if I put 15 mils in the bag, that extra 0.1 probably is not going to break the bank, so to speak. We'll still get proper pain management on the pet. So those types of things are up to you. I encourage everybody to always do out the math as much as you can and figure out how to be as accurate as possible. But when it comes down to splitting hairs of, is that 0.1 going to make a difference in a 15 kg animal? No, probably not. So now we have, let's say, 15 mils that we're going to put into this bag. Okay, next part of the equation is quantity sufficient. So quantity sufficient means if you're going to add to the bag, you first have to subtract from the bag. If you start with 1,000 mils, you have to end with 1,000 mils. So if I'm adding 15 mils into a 1,000 mil bag, I don't have 1,000 anymore. I have 1,015. But that's not what I did the math on. So what I'm going to do from that 1,000 mil bag, I'm going to draw out 15 mils. I'm going to grab my 20 mil syringe. I'm going to remove 15 mils from the bag, and then I'm going to add in 15 mils of morphine. And when I do that now, I have a total volume of 1,000. So that's what quantity sufficient is. Once you have that total of 1,000, now you can shake up your bag. You can label the bag appropriately, spike the bag, and start running it on your patient at 50 mils an hour. And you know that will equal the concentration you picked in the way in the beginning, which is 0.5 mg per kg per hour. All right, so that's that chunk of it. Now let's say your dog at 0.5 mg per kg per hour is not responding to the drug. He's still painful. He still hurts. So here's how we figure out if I'm going to run the bag at a higher rate, then what is my concentration? I can't just start running it at a higher rate without doing the math part, because at some point you're going to run it too high, meaning you're going to be outside of the dose range that is safe for the pet. All right, so this is a proportion, how we set this up. Let me erase some of these bits. Okay. What we're looking for in a proportion means that this part, 50 mil per hour, which is the same as the 0.5 mg per kg hour, I need that to equal the same as if I'm going to increase my rate to 75 mils an hour. So that's just cross multiplication when you're doing a proportion. So you've got 0.5 times 75, 0.5 times 75, and then you got to jump over here and divide it by, this is times and that's divided by 50. Oh, I did something wrong. 0.5 times 75, and then divided by 50. So now this says 0.75 mg per kg per hour. So that's still within the dose range. Let's go back up and look at what Plum said. Plum said I can do 0.1 to 1 mg per kg per hour. Well, good. Okay, so let's go up a little higher. If I go up to 100 mils an hour, what is that going to get me? Again, you just cross multiply. 0.5 times 100 divided by 50 will get you 1 mil per kg per hour. So that is the highest amount we can go, 1 mg per kg per hour. And you can see I did the math out farther. I said, well, what if I run it at 125 mils an hour? That got me to 1.25 mg per kg per hour. That's too high. So the highest I can go is 100 mils an hour to get him to 1 mg per kg per hour. Now that's not to say there aren't a lot of numbers in between 100 and 75. And there are a lot of numbers between 75 and 50. So if I go from 50 to 60 and 60 to 70, titrating up slowly to see where he actually responds to the morphine, that is okay. This math, what I'm saying with the math is, we need to figure out where the top dose is. I can only go so high. So I needed to figure that out. You can look at it from the other way too. What do you mean the other way, Sheree? Well, I mean, if Plum already told me it's 1 mg per kg per hour, which is the highest I can go, there you are. I can take 50 now times 1 divided by a half. 50 times 1, oh gosh, here we go, 50 times 1 divided by 0.5. There we are, 100. 100 mil per hour is the highest I could go. So that was the easy way to figure out how high can I go. Got it, done. But if you're going to write in your medical record, I turned him up to 60 mils per hour, which equals what rate, which with this math is pretty easy. It's actually 0.6 mg per kg per hour. So I turned him up to 60 mils, which is equivalent to 0.6 mg per kg per hour of morphine. There you go. Now you can properly write it in the record. And somewhere you could even note not to exceed 100 mil per hour, because that would be higher than the recommended dose rate of morphine. All right, so the max dose, there you go. Now if we look at multi-pet CRIs, usually with the multi-pet CRI, I try to make it as easy as possible for me. I'm just going to run everything at 1 mil per kg per hour. So this is not the same as the rate of the drug. This is just me figuring out what milliliters am I running this at so that it can fit any patient, because I'll plug in their kilograms, and then I'll end up with the proper rate. So what do we start? We choose the size of the